Hello, you absolute legends. For part A of the acid-base titration, our goal is to calculate the molarity of the sodium hydroxide, the base, solution. Now the units, molarity, are moles over liters. If our goal is to get the molarity of the base, sodium hydroxide, we have two units, moles and liters. We need two calculations, two instruments, two measurements. One to calculate the numerator and another one to calculate the denominator. The denominator is the easier one to start with. The denominator is determined from the burette. This is a glass burette that has markings on here. You'll record the initial volume and the final volume in milliliters. Subtract them to get the volume in liters. So for the goal, this is how you calculate the denominator. The numerator, moles, we use another instrument to determine the moles. We need to know something first off. We need to know the ratio that the acid and the base react together. The acid and the base react in a 2-to-1 molar ratio. Therefore, we can back calculate. If we know the grams of acid used, we can determine how many grams of base would be consumed. So we start with however many grams of acid this is the amount that you weigh in lab on the balance. So I just have kind of a filler number here. We need this in moles. So the molecular weight of oxalic acid is 90 grams per mole. And I have a unit canceled out in here. And then the moles of acid and moles of base is in a 2-to-1 ratio. So I'm going to put this from the balanced chemical reaction in my scaffold to get the moles of base that must be consumed. This calculation is done for every trial using the amount of acid that you weighed on lab day. That gives you the numerator, the moles of base that must be consumed. The denominator is what you get from every trial, the volume of the burette, the final minus the initial. I hope this helps.